Hello and welcome to Chapter 7, Section 1, Earth Science. We're going to be talking about resources, mining, and general extraction. So, start off with the Earth contains a great deal of the resources humans need. In fact, you could argue it's the origin source for everything that we need to live. Between that and the sun, it's all we've got. So, what we're going to focus on this chapter is actually going to be things that we pull out of the ground. So, yes, nutrients are important for plants to grow and plants maintain life as we know it. That's true. But we're going to focus in on some of the rocks, some of the metals, some of the non-metal resources that we'll need to run our lives and manufacture and keep everything on board as we know it. So, as far as resources go, metals, there are some very straightforward ones. Au is gold, Ag for silver, aluminum, other native elements such as copper. Some of these are found in pure forms. The vast majority of the time, they're in compounds. They're stuck with other minerals, other metals sometimes, and they've got to be separated and extracted. And that's a whole process that we won't really get into. But other options are nonmetals. So maybe we need sulfur or silicon or oxygen. All of these can be found in different forms, different compounds, and they can be located in the earth. They're mined. So on your left there at the bottom, this is the Orme copper mines. I believe I'm saying this right. Believed to be the largest ancient mine set in the known world, located in the UK. People have been extracting minerals for a very long time. Over on the right, the Myrny diamond mine over in Russia, largest open pit mine in the world, currently as far as I know. And for scale, you see that red arrow pointing down here, that tiny little dot, that's a car. To put this in perspective on scale. Absolutely massive structures, and a great deal of earth has been moved in the process. Most of the time, these resources that we're after are referred to as ores. They're mineral deposits. They are sufficiently enriched that we want to extract something valuable from them. So, in simplified terms, if you look at an area and you say, okay, this has got a lot of whatever we're after, a lot of diamonds, a lot of gold, a lot of copper, a lot of calcite, whatever it may be, this is the area where we want to pull from. We want to mine here, we want to extract it. And there's a few different ways that these ores are formed. One is cooling magma. So we talked about before in an earlier chapter that all of these crystals begin to form, well, maybe in the liquid. If they've got liquid metal, the metal is denser. Just like the crystals, it starts to fall to the bottom and gravity settles out, and we have a large concentration of metals at the bottom of the opening or the chamber, if you will. Over time, that's going to cool, and later in life, much later, people will dig through this and say, aha, look at all the metal that's right here. Well, it settled out a long time ago. That's how it got there. Other option is contact metamorphism. Again, something we talked about last chapter, but we've got heat that's come up into an area, and it can either metamorphose the rocks around it, where things start to line up and maybe some of the metals or whatever you're after starts to form bands. Other option is hydrothermal vents and pressure. It'll force extremely hot water up and away. That hot water may have some metals that are of interest in it. As it forces its way up and through, it starts to cool down, and what we're left with over here are veins, deposits. These are, with some regularity, maybe not these in particular, but how gold is formed. Frequently along hydrothermal cracks and vents where things cooled down, it solidified, and it precipitated there. So you're left with an enriched area behind it. Let's see. This is the way we also get lode. So These are minerals and veins in a small region. It's called a lode. If you've ever heard the term looking for the mother lode, this is actually referred back to miners back in California in the gold rush back in the 1840s. They were looking for the mother lode, the one that contained massive amounts of gold, and that's what they were searching for. One thing I forgot to mention earlier, over here in the magma, this tends to be a lot of the heavier metals, chromium, nickel, lead, but the ones that are heavier, the ones that are really going to separate themselves out and settle to the bottom. And finally, moving water will accumulate ore. So again, you're usually looking for things that are heavier. So if you've got metals, if you've got gold, we'll keep using that example. When it's coming off a little waterfall here, it's going to start to pile up. And maybe a little bit of it doesn't settle out, it gets caught. And all of these little black dots here are representing some form of a mineral, some form of ore that they're interested in. And if you'll notice, it's where the water kind of slows down is the best way to describe it. We frequently see this. These form placer deposits. We'll talk a little bit more about those later, but the general idea is the water slowed down enough. It was carrying the gold, or it was carrying the silver, or whatever resource you're after. And because it slowed down enough, it was able to fall out of the water. It wouldn't continue to be carried. We also go after non-metallic ores. So gemstones, if they're cut properly, are going to display an incredible brilliance. So these could be your diamonds and your rubies and your sapphires and any number of others. And over on the left, you see this is someone mixing cement. We use calcite. We use gypsum. We use a number of other non-metallic ores every day, and those have to come from somewhere. So not everything is a precious metal or gemstone. Sometimes it's pretty basic stuff, but it's stuff we need for everyday life. Exploration, how to find the proverbial mother lode, trying to find areas. It's done in a variety of ways. There's a lot of technology out there now because there's a lot of money involved in mining. But most frequently, it comes down to an understanding of geology. What were the rocks around? What kind of heat was present? What kind of tectonic activity was around? How did things shift? How were they get concentrated? Airplanes can be used. They can have any number of sensors that are available, but they can also just look for changes in the land surface. They'll scout out areas and say, all right, let's go here, let's look here. You can also start to see sample analysis. People will drill cores. They'll take samples. They'll say, oh, okay, look, I've got this much resource here, this much resource there. I'm going to concentrate my efforts here. In general, to be considered an area worth digging into, so to speak, worth exploring, the site needs to contain 100 to 1,000 times more of whatever material you're looking for than the surrounding area. So if you're running all of these different tests and you want to say, all right, I want to start mining here. Before it's worth mining, it's got to have at least 100 times more material present than anywhere else. Otherwise, economically, probably not worth your time to mine there. There are a few different options as far as mining goes. One is subsurface. This is the one we traditionally think of. So we've seen the photos and the pictures and maybe even movies where they talk about coal miners down in the pits, down in the coal mine. Well, that's what we see on the right here. Vintage photo here, but people have been mining coal for a long time. Over on the left, a little bit more of mechanized, machinery-based operation. No longer people down there with picks and shovels and buckets and push carts. Now we're much more into mechanized machinery and conveyor belts and things that are honestly still dangerous, but not nearly as much as they used to be. Surface mining, these are huge open areas, open pits. They'll frequently be dug down. We look on the left there. This is a large open pit mine. The reason they cut all of these little grooves into the sides of the walls here, they're used as roads. So the bulldozers will push the material out, push the material out, push the material out, but they'll leave these ledges, and that's how they actually drive. That's how they are able to take the material from the bottom here and drive it all the way back up. The machines they use to load them on, to put this in perspective, this is a full-sized automobile here getting crushed. This is the size of one tire that can roll over a normal-sized vehicle in some of these earth movers. And this is a transportation, kind of a dump truck, if you will, that got loaded up. So absolutely huge operations. To do this, they'll strip away the rocks or the soil and everything above it and get down in and dig out the ore that they are after. This is a surface mine. Placer minings, this is when the water concentrates the minerals in a certain area. So again, we'll go with gold here. This lovely picture on the left shows someone gold mining. Well, this is extracting a placer mine. The idea that gold settled into an area a long time ago where the water slowed down, well, this guy's out there trying to find it. He's trying to extract it and put it through well, I guess it's a sluice box there technically, but general idea is he's trying to get the gold out. Modern day systems, much more mechanized. They'll put buckets, and sometimes it's more of a conveyor belt system that will go down. They will dig out the material. They'll bring them back up. It'll filter through. Maybe they're using water. Maybe they're using some other system or shaker tables or something like that. They extract what they're after, and then the rest of the sediment gets dumped back in place. So even though they're on this giant barge, a system with rigged pulleys and all, they don't have to carry all of the rock and all of the soil and the sediment that they take. They just pull what they want out from it and put the rest back. And there's also undersea mining. So over here on the left, these are all nodules, lumps of minerals that have been, for some reason or another, put together, precipitated out on the seafloor. A lot of magnesium, some other elements that can be important will show up here. And one of the possible operations they've got going here are these machines. Sometimes it's put down, there's kind of a large scoop that comes from a boat that is going to dredge these up and pull them up. Sometimes they have kind of a rover system that is collecting these, as we see in this picture. Either way, you're extracting the minerals from the bottom of the ocean down on the seafloor. So again, a handful of different options. This is a quick overview of Section 1. Hopefully this makes a little bit more sense.